Welcome to this introductory tutorial on basic data plotting with EZL. In this video, we will focus primarily on data importing techniques. We'll see how EZL makes it easy to quickly plot data of various sizes and formats, and we'll discuss some of EZL's basic data manipulation functions. More advanced features are covered in other videos, or you may visit ezelsoftware.com/support to view the online user manual. There are multiple ways to import data into EZL. For example, you can run EZL with parameters from a Windows command prompt. You can drag and drop files directly from Windows. You can execute the EZL command using the built-in command window. Or you can use EZL's directory browser to double-click or drag and drop files. We'll start with this technique as it is perhaps the simplest. But before we do, let's take a look at the data which we're about to plot. To do so, I'm going to right-click on the file signTable1.dat and select View/Edit. The file will then open in the text editor of your choice, configurable in the default settings page within the system toolset. I have mine set to Notepad++. So here we see that the file is a simple 3-column data set with a single header row. Now let's plot it. When we drag and drop files onto a plotter, we're presented with a file setup dialog. On the left we see the files which we are configuring, in this case just the one signTable1.dat, and on the right various settings and options. As we saw, this file contains a header, so I'll set the header row to 1, and we'll see row 1 turn gray in the data preview table. To keep things simple, we won't do any data scaling, but let's go ahead and plot both columns 2 and 3 against the time column 1. So I'll select the third column to be our Y2, and upon doing so, we see a new scaling tab appear in case we wish to scale or add or subtract any constants to the Y2 data, which we do not in this example. Now when we drop down the column designator box to set Y2, you might have noticed that there is only Y1, Y2, and Y3 available. What happens if we have a file with more than 3 columns? Well, when there are more than 3 columns available, there will be designators available for them. This file only has 3 columns, so only Y1 through 3 is necessary. So now I'll click OK, and the data is plotted. We're happy with the data, but we would like to add the data contained in signTable2.dat. Let's see how to do this. We're basically going to do the same as before. The only difference is now we're going to click the Append checkbox here above the OK button to tell EZL that we do not wish for it to clear or replace the existing data, but instead to append or add these new data sets to the plot. Click OK, and we see that our new data has been added to the plot. Our legends could use a little customization though. Right-clicking on a legend item displays the legend options menu. I'll increase our font a little bit to make it easier for you to see. Now the legend text can be changed with a simple left click for each item. But it is often easier and faster to use the legend command in the command window. The /pi that I used tells EZL to convert pi to its Greek character representation. EZL has many such special characters, and you can type help space / in the command window for more. Now, for the purpose of demonstration, we went about this in a slightly roundabout way. But let's see how we could accomplish this more efficiently. One way is to drag both files onto the plotter simultaneously. Multiple files can be selected in the directory browser using the Shift or Control key on your keyboard. We can configure all files, too, in this case, with matching parameters by clicking on all files in the list box on the left. And again, I'll set our legend using our legend command. Using the file setup dialog is convenient, but all it really does is create the EZL command syntax for you. We could just do this ourselves. Here I'm using the skip option to bypass the first line, or to skip the first line of each file, which was the header row. Since we're using the legend, since we're setting the legend manually anyway, we don't need the header row anymore, and I'm including the -legend option within the EZL command in order to set the legend all in one command. Note that the asterisk is used in our -f option, which tells EZL to read files which begin with signed table and end in .dat. And to finish our plot, I'll set our title and our X and Y axes. Now for our next example, we'll discuss plotting files where the data curves are not separated into columns, but instead are interleaved. For example, here we have a file which represents the velocities of 2 race cars over time. The curves are interleaved, and the third column specifies which car each row corresponds to. Our goal is to separate out each car's data in order to plot the 2 unique curves. It sounds complicated, but turns out to be quite simple. The EZL command has a -k option to specify the key or identifier column. So if we drag the file onto the plotter, designate the first row to be our header, we can set the third column to be our key column. And if we click OK, we see that our 2 race car curves are plotted. Now suppose instead we wish to plot the curve for just one of the cars, say car 4. There's no way to do this with the file setup dialog, but we can amend the command which was just built. Press up and add a -regx car 4 to the end. With EZL you can use regular expressions for line matching. While regular expressions is a rather complex subject, for now it's enough to know that this option will instruct EZL to only use lines from the file which contain the matching pattern, car 4 in this case. Any other lines are ignored. In fact, now since we're only reading in a single curve, we could do away with the -k option. Note that I was able to quickly recall the last command by pressing the up arrow on my keyboard. You can use the up and down arrow keys to traverse through your command history. You can also type history to display your recent command history. You can change the number of commands retained by the history cache by clicking the default settings button in the system toolbox. While regular expression syntax is beyond the scope of this tutorial, it's worth mentioning here that EZL does include a simple regular expression tester, which can be used to assist you in debugging regular expression syntax. And if we enter car4 as used for our previous matching pattern and click match lines, we see that our search highlights only those lines which contain car4. To demonstrate more powerful regular expressions, suppose we want to plot only the data from time 0 to time 0.4. Without proof, I'll change our regular expression syntax to this. And we see that our two cars are now plotted using the data only which matches times 0 through time 0.4. For our next example, we'll see how to plot data which is time-stamped with calendar dates and times. Calendar dates and times often pose a problem for plotters. For instance, how does the software know whether a timestamp is given in month, day, year, or day, month, year? For example, let's look at this file. The year is clearly 2014, but was the data taken on March 2nd or February 3rd? And what if we had abbreviated the year from 2014 to just 14? And we would have additional complications. EZL solves this through the use of date-time specifiers. Let's try it out. We'll start by declaring our first column as the date column. Now up top we have a date tab. Here we can format the date using the appropriate specifiers. The drop-down box provides some commonly used formats, but you can modify these to use your own if needed. I'll select this one and confirm that the example shows the expected results. Note that the capital Y and lowercase note that the capital and lowercase letters within the specifier have very specific meaning. For example, if I change the capital Y to a lowercase y, the example demonstrates that the year is now expected to be in an abbreviated 2-digit form. So I'll change it back to an uppercase Y. Now I'll set the second column to represent time, and I'll check the time format. But what do we do with the AM/PM column? Well, we want this to be consumed by the time column, so I'll make a slight adjustment to the time specifier and add a space AM. I could have typed PM as well, or even dash dash. Either way, EZL will view this as a space plus 2 additional characters to analyze. In doing so, EZL will figure out that the time is in 12-hour format, with AM/PM defining the appropriate half day. Now I'll set the final column to Y1 and click OK. We see that it takes slightly longer to process interpreted data such as calendar and timestamps, but in the end we have our plot of slightly more than 1 million data points. But what happened to our timestamps? What we are seeing along the x-axis is the MJD, or modified Julian date representations of the timestamps. In EZL, MJD is always the underlying numerical format for all calendar date imports, but we can always convert the grid labels to calendar date times by clicking MJD to date time from within the Grid Adjustments toolset. By default, only the date is displayed unless the time span is small enough to where the times are needed to unambiguously label the grid. For our final example, we'll see how to plot files in bulk. It's common practice for long-term data acquisition or data collection systems, for example, temperature sensors, to package streaming data into hourly, daily, or weekly files, probably depending on the sample rate of the system. EZL is well suited to handle files in bulk. To facilitate this example, let's start by producing a large file of random data using the noise generator located within the Precision Timing toolset. We can then split the file into pieces to simulate a data collection system. Now, for those of you in the precision timing community, you probably know that white frequency noise produces a nice random walk in phase, which is perfect for this example. Let's use, say, 5 million points. That should give us plenty to work with, but also demonstrate the speed at which EZL is able to not only handle large data sets, but generate them as well. And now that we have our master set, let's save it to the hard drive. Now, to split the file, we'll use the Linux-based split command in Cygwin. And let's use maybe 200,000 lines per file. And check that our directory is full. And we see that the file is split into 25 separate files. Now let's plot the file using the command EZL space -f(x) asterisk, so that we will import all files which begin with X and end with anything. And we're going to use legend pos off to set the legend position to off. Because we're plotting many files, the legend would probably be more in the way than useful, so it's best here to turn it off. As we can see, the command yields 25 plotted data sets, one for each of our input files. Because the colors used for the data sets repeat, we're left with some ambiguity in identifying where each file fits into the overall plot. For this, we can use the curve identifier panel to resolve which file is which. We simply click on an item and it will flash, revealing its data. Now, while we do have all of our data plotted, we have each file plotted as a unique data set. Sometimes, however, it is more desirable to treat each file as a single slice of a larger data set. In other words, we would like to have all of our data concatenated together. On the toolbar, just to the right of the eraser button, there's a data selection button, and we can use this to combine data. So if we drag a box encompassing all of the data on the plot, we'll see that our selected data has now been combined to a single data set. Alternatively, a better method is to use the -merge option in our original EZL command. And the merge option does just what you might expect. It merges or concatenates the data together as it's being read in. And if we click the stats button or type stats into the command window, we see that all 5 million of our original data points are represented. We hope that you've enjoyed this introductory video on plotting in EZL. For questions or comments, please write to us at info@ezlsoftware.com.